Hey everyone, and welcome back to the AI Tech channel. Today, we're diving into a question that's probably on a lot of your minds. Are large language models, or LLMs, actually good enough to replace engineers in the real world? I know, it sounds like a headline from a sci-fi movie, but the hype around AI is reaching fever pitch. We're constantly told about these incredible breakthroughs, but are they living up to the promise? Or are we being sold a dream that's just not ready for reality? What if I told you that the latest research suggests that LLMs are nowhere near as capable as we think they are? Let's find out. Okay, so let's start with the news. A recent study from Apple engineers has exposed some pretty significant weaknesses in the reasoning capabilities of LLMs. Now, we've heard companies like OpenAI and Google talking up these advanced reasoning skills as the next big thing. But this study throws some serious shade on those claims. The Apple researchers found that even seemingly trivial changes to common benchmark problems can completely throw off these models. We're talking about things like swapping out names or numbers in math problems. It's like you change Sophie to Bill, and suddenly the AI's brain melts down. That's not exactly reassuring, is it? Speaking of OpenAI, there's also buzz about the upcoming release of ChatGPT 3 Mini. The whispers are that it's going to be faster and cheaper than previous models, maybe even better than o1. Now, that might sound impressive, but it also highlights the focus on speed and cost over actual, robust reasoning. If the new model prioritizes speed and cost, how much emphasis will be placed on accuracy and reliability? What could be the consequences if it's released prematurely? And it's not just academic studies. We're seeing real-world examples of AI failures popping up all over the place. We're talking about AI chatbots making false accusations, news aggregators posting inappropriate content, and even AI being used to create deepfake scams. I mean, come on. Just recently, an AI meal planner suggested a recipe for chlorine gas. Chlorine gas? That's not just a mistake. That's a potential disaster. The number of AI mishaps continues to rise, and it's raising serious questions about the reliability of AI. So, what's going on here? Well, the Apple study points to a fundamental flaw in how LLMs operate. They're not actually reasoning in the way that humans do. Instead, they're relying on probabilistic pattern matching. Think of it like this. They're really good at spotting patterns in data, but they don't actually understand the underlying concepts. The researchers hypothesize that LLMs aren't capable of genuine logical reasoning. Instead, they attempt to replicate the reasoning steps observed in their training data. This means that if they encounter something slightly different from what they've seen before, they can easily get confused. The Apple researchers used a modified version of the GSM-8K dataset called GSM Symbolic to test this. GSM-8K is a set of grade school-level math word problems. What the researchers did was to modify the dataset to dynamically replace certain names and numbers with new values. This avoids data contamination, where the model has already seen the exact questions in its training data. The results were pretty striking. When they tested over 20 state-of-the-art LLMs on GSM Symbolic, they found that accuracy dropped across the board compared to GSM-8K. Some models saw performance drops of up to 9.2%. And what's worse, changing numbers resulted in worse accuracy than changing names. This suggests that LLMs are more sensitive to numerical variations than conceptual ones. This fragility highlights a major problem. LLMs lack the formal understanding of underlying concepts needed for truly reliable mathematical reasoning capabilities. They can perform well on standardized benchmarks, but as soon as you throw them a curveball, they fall apart. It's like they're memorizing answers instead of learning how to solve problems. This is a huge issue because it means that we can't really trust them to make critical decisions in real-world scenarios. The implications of this lack of understanding are far-reaching. Let's talk about data contamination for a second. This is a crucial concept in AI research. It refers to the situation where a model is tested on data that it has already seen during training. This can lead to artificially inflated performance scores because the model is essentially just regurgitating information that it already knows. The GSM Symbolic dataset was designed to avoid data contamination by dynamically changing the names and numbers in the problems. This ensures that the model is actually reasoning rather than just memorizing. Another key term is probabilistic pattern matching. This is the technique that LLMs use to generate text and make predictions. They analyze vast amounts of data to identify patterns and relationships between words and concepts. When they're asked a question, they use these patterns to generate the most likely answer. However, this approach doesn't involve any real understanding of the underlying meaning. It's just about finding the patterns that best fit the input. What happens when the patterns mislead the model? That's when we see the failures. And then there are hallucinations. This is when an AI model generates information that is completely false or nonsensical. We've seen examples of this with ChatGPT making up fake legal cases and MSN News publishing articles with fabricated headlines. Hallucinations are a serious problem because they can lead to misinformation and damage trust in AI systems. They're also a sign that the model doesn't really understand what it's talking about. How do we prevent these hallucinations from happening? The Apple study I mentioned earlier is titled GSM Symbolic: Understanding the Limitations of Mathematical Reasoning in Large Language Models. It's currently available as a preprint paper, so you can check it out for yourself. The researchers are insert names of Apple researchers. It's a really interesting read and provides a lot of valuable insights into the current state of LLM reasoning capabilities. I'll put a link in the description so you can check it out. Now, I know what some of you are thinking, but AI is improving so fast. Surely these problems will be solved soon. And that's a fair point. AI is indeed advancing at an incredible pace. However, it's important to distinguish between incremental improvements and fundamental breakthroughs. We're seeing a lot of incremental improvements in areas like speed and efficiency, but we haven't yet seen a fundamental breakthrough in reasoning ability. It's possible that these problems will be solved in the future, but it's also possible that they represent a fundamental limitation of current AI architectures. Another argument is that we don't need general-purpose AI that can do everything. We can create specialized AI models that are trained for specific tasks. And that's true to some extent. But even in specialized domains, we need to be able to trust that the AI is making reliable decisions. If an AI is being used to diagnose medical conditions or manage financial investments, we can't afford for it to make mistakes. How can we ensure that these specialized AIs are truly reliable? So, how can we verify the reliability of AI systems? One approach is to use red teaming. This involves hiring experts to try to break the AI system and find its weaknesses. Red teaming can help to identify vulnerabilities that might not be apparent during normal testing. It's like hiring a hacker to try to break into your computer system. By finding the weaknesses, you can then fix them and make the system more secure. This kind of rigorous testing is essential for ensuring that AI systems are safe and reliable. Another important aspect is interpretability. This refers to the ability to understand how an AI system is making its decisions. If we can understand why an AI is making a particular recommendation, we can better assess its reliability. Interpretability is especially important in high-stakes domains like healthcare and finance. We need to be able to explain why an AI made a particular diagnosis or investment decision. Without interpretability, it's difficult to trust AI systems. Okay, so let's bring it all together. The evidence suggests that LLMs are not yet ready to replace engineers in the real world. They lack the robust reasoning capabilities needed to handle complex and unpredictable situations. They're prone to errors and hallucinations, and they can be easily fooled by seemingly trivial changes. While AI is improving rapidly, we're still a long way from achieving truly reliable and trustworthy AI systems. This doesn't mean that AI is useless. It can be a valuable tool for automating tasks and augmenting human capabilities. But we need to be realistic about its limitations. It's like giving someone a calculator. It can help with math, but doesn't make them a mathematician. So, what does the future hold? I think we're likely to see a shift towards augmented intelligence, where AI is used to enhance human capabilities rather than replace them. Engineers will still be needed to design, build, and maintain complex systems. But they'll be able to use AI tools to help them with tasks like data analysis, problem-solving, and decision-making. The key is to find the right balance between human expertise and AI automation. How do we find that balance? Ultimately, the question of whether LLMs can replace engineers is a complex one with no easy answer. The technology is still evolving, and we need to continue to monitor its progress and assess its capabilities. But for now, it's clear that human engineers are still essential. What do you think? Are you worried about AI taking your job? Or are you excited about the possibilities of augmented intelligence? Let me know in the comments below. And don't forget to like and subscribe for more AI news and analysis. Thanks for watching.